Okay, so hopefully you took a few minutes to go through these. Let's just look at answers. So if I look at this, each of these trinomials, all but one, can be factored into two binomials multiplied. So here we have x minus 6, x plus 3. Here we have r minus 3, r minus 3. So you could have said r minus 3 squared. Here we have a plus 9, a minus 7. Here we have x plus 3, x minus 3. And here we have y minus 8, y minus 8. So you could have said y minus 8 squared. So all of those are actually special patterns. The only one that I think is important, because the others will kind of just fall out, but this one is helpful to understand. So difference of two squares is when I have a perfect square minus a perfect square. That's going to split up into the square roots. One added, one subtracted, so that when you're multiplying this out, if you remember by using FOIL, the middle term is going to go away. So the other one that we were seeing was this, the perfect square trinomial. I don't really think that's worth remembering as a pattern in and of itself, because it will just kind of fall out. All right, so here's where we need to get back into the parts that you might have forgotten or might not have practiced as much when you were in Algebra 1 and geometry. But factoring with the leading coefficient is where we want to focus most of our time today. Oops. Okay, so I'm going to show you a couple of different ways. Hopefully one of them hits how you did it or how you learned it. If neither of these are the way you learned it, you may want to ask me to go over the way if you've forgotten. Okay, so if we remember, excuse me, there is our quadratic in standard form, ax squared minus bx plus c. They're all going to fit into that. If you remember the x part of this, where on top you are putting these two, the leading coefficient and the constant term, you're multiplying them. So 5 times 2 gives us with 10. That's the a value times the c value. And then on the bottom part of our x, we put the b value. Okay, and I'm not sure why I put minus here. Let's make that a plus. All right, so here's what we're going to do by grouping. It's going to start by figuring out what two numbers multiply to be this 10 and add to be this 11. So things that multiply to be 10, add to be 11 are 10 and 1. Okay, so now we're going to rewrite this trinomial as two different binomials, and we're splitting it up. Well, so just watch what I'm going to do here. I'm going to take the first term, 5x squared. I'm going to take the last term, the plus 2, the constant term, and what I am doing is splitting up this middle term into these two pieces. So I'm going to say plus 10x, and then this is adding, right, 1x. So I've rewritten what was 3 terms into 4 terms, and I've got them grouped together. Okay, now what I'm going to do is pull out whatever is common to each term. So you can see in the first pair of terms here in the first parentheses, I can take out a 5x. That leaves x plus 2. In the second one, there's not really anything I can take out, so what I'm going to think about it as is taking out a 1 and leaving x plus 2. Okay, so now you can see that both of these pieces are multiplied by x plus 2. So I'm going to factor out the x plus 2. In the first group, that leaves 5x. In the second group, that leaves plus 1. So my factored form of 5x squared plus 11x plus 2 is x plus 2 times 5x plus 1. Okay, let's do another one so that you can see that again. Okay, so now remember, I want to take the leading coefficient times the constant term. That's what goes on top. I'm going to take this middle term and put it on the bottom. So I'm looking for 2 numbers that multiply to be negative 60. So I know one of them has to be positive, one of them has to be negative. I know the bigger one has to be positive because when I combine them together, I'm going to get a positive number. So when I think of those numbers, I'm going to come up with, and what you may want to do is make a little chart of all of the numbers that multiply to be negative 60. Okay, I would come up with 12 times negative 5. So now I'm going to take the first term. I'm going to split this second term into plus 12x and minus 5x. So our x over here allows us to split that term, that middle term, into 2 pieces, and then I have minus 15. I'm going to group these into two groups here. Okay, then I'm going to look at what can I factor out. Well, in the first group, I can factor out 4x, which leaves x plus 3. Second group, I can factor out a negative 5 and also leave x plus 3. So we're always trying to have what we're leaving be the same so that I can factor that out, x plus 3, and then what's left is 4x minus 5. So 4x squared plus 7x minus 15 in its factored form is x plus 3, 4x minus 5. Okay, we're going to look at another way if that's not the way you've done it. Maybe you've done it using the X box. So this starts the very same way. What I am doing is taking my leading coefficient, my constant term, multiplying them to get this 30 on top. Then I am taking the middle number, and it goes on the bottom. I'm looking for 2 numbers that multiply to be 30 and add to be negative 17. So this is kind of what I was saying on the last one. Maybe I don't remember right off the top of my head, and I want to just quickly make a factor table. So if I multiply 1 times 30, I get 30. If I multiply 2 times 15, 3 times 10, 5 times 6. So I'm looking for the two numbers that are going to multiply to be 30, which is all of those, and combine to be negative 17. So if I am multiplying to be a positive, but adding to be a negative, I have to know that both of them are going to be negative. Okay, so the two that are going to fit that are negative 2 and negative 15. So what the X box does is what grouping did, but I think it makes it maybe easier to see. So what we do is take that first term, so 5x squared, put it in the top left. Take our constant term, put it in the bottom right, and then take the two numbers that we broke down here. We broke the negative 17x into negative 2 and negative 15. So I have negative 2x and negative 15x. So now we're going to use the columns or the rows to pull out what is common. So if I look across here, I can take out a 5x. Then I'm just going backwards in the box saying, if I multiply 5x times what do I get 5x squared? Well, I need to multiply it times x. Then I say if I multiply 5x times something, I'm going to get negative 15x. Well, that's negative 3. Then I look and say, what do I need to multiply x by to get negative 2x? That's negative 2. So this 5x squared minus 17x plus 6 breaks down or factors into 5x minus 2 times x minus 3. Do one more with the box method. Okay, so I am multiplying 6 times 35, so I get 210. Taking the middle number, negative 31. So I'm looking for two numbers that multiply to be 210, add to be negative 31. So you might want to make your little table of all the factors. If I do that, I'm going to come up with negative 10 and negative 21. So negative 10, negative 21, multiply to be 210, add to be negative 31. I'm going to take the numbers, the terms from the first and the last, right? My x squared term, top left, my constants term, bottom right. And then I've broken down this negative 31x into negative 10 and negative 21, so they both have an x. And I'm just using the box to be able to see what I'm multiplying, right? So I'm going to look this time down this column. What can I pull out of 6x squared and negative 10x as a common factor? Well, I can take a 2x. What do I need to multiply 2x by on this left side to get 6x squared? That is 3x. What do I need to multiply 2x by to get negative 10x? That's negative 5. What do I need to multiply 3x by to get negative 21x? That is negative 7x. Okay, and I didn't mention in the first one, I should double check that the number I'm getting here, oops, and I'm so sorry, I did not mean to write an x here. So it's good that I checked. I double checked that I'm getting positive 35 when I multiply this number times this number. So 6x squared minus 31x plus 35 factors into 3x minus 5 times 2x minus 7. Okay, so I would pause the video I would look at each of these and try whichever method you like. So pause if you don't want to see the answers. I'm going to show the answers real quickly here in just a minute. Okay, after you come back from a pause, here are your answers. Okay, so that is the factoring with the leading coefficient that is not 1.